Okay, so hello class. We still have a couple of minutes, but as usual, let me take a couple of questions before we start. So again, as usual, I guess these remaining slides are already from previous lectures. You already have the slides, and the ones that we are going to move to afterwards are also already uploaded on Avenue for those who wants to keep notes on slides. Okay, we are starting from here, I guess. Yolanda, yes, the exam is on December 10th. That's correct. Okay, thank you. So, by the way, how is the lab 5 going? Do you have any questions with regard to the lab? It's fine. I have already uploaded. The tutorial video that is giving some hints on the starter code as well as the lab questions for you to look back when you're working on the lab. How will the exam work with both C and Java? Good, that's a good question. I guess in the coming tutorial, I might also spend some time discussing in detail how to approach the exam and have some exercises. But generally, the thing is the following. So since we are using a different Eclipse IDE for Java, I have shown this, I guess, also in the last lecture. You should be able to open both Eclipse IDEs in the same machine and they work completely fine. You shouldn't have any problem. This is one thing. The second thing, and in fact, this might be my advice, if you want to directly, so I will be, I would say, more lean in the final than the midterm. If you want to just answer in the GitHub web page, and if you find this easier, well, that's completely up to you. You can also use any online compiler to check your code. Oh, so you guys still hear me? Oh, there is some lag. That's interesting. Oh, I see now the internet connection. Okay, so I should be back right now, I guess. Okay, thanks everyone. So what I was saying is, I would be more lean in the final than the midterm in the sense that if you want to use directly the GitHub web page for answering questions without caring about like push pull and all the Eclipse related issues, that's completely fine. And you can also use any online compiler if you want to check your code. For those who want to prefer to stick to the environment that they are familiar with, which is Eclipse, this should also be, I would believe it's the more efficient way, the more professional way, but it's completely up to you. You have the option to use either. In the tutorial also, I can show again how to open both Eclipse in your machine, like the C and the Java one. Another point related to the final is, as I said before, the C would be only 1/3 of the exam, and Java will be almost 2/3, right? So this is what you should expect in the final. All the lectures are already uploaded on the YouTube, including the Friday lecture. So you should find it in the channel and the tutorial as well. Okay, good. Any more questions before we start? Give us another demo like last time where we tried pulling and pushing to make sure we can run both IDEs. Yes, sure. I might also try to do this. Another thing we can try is give this a kind of exercise or dummy test before the final, similar to what we have done in the midterm, to make sure you guys know all the process well before the final. I need to check this, yes, but I guess I have uploaded all of them yesterday. Let me recheck. Might be not visible, or let me check after this lecture. I guess it might be only still processing or something like this. Okay, good. So let's go back what we started to what we started last lecture. Let me just go full screen here. Oh, why there is this Slack thing in the PowerPoint? Okay, so I hope you guys are able to see the full screen. So last time, what we have done to discuss inheritance, we started again from the class we all know, which is the point class. And we created another child of this class, which is the circle class. And I have shown you both in slides and in brackets as well, including online GDB, of how to interact with this child class, what it means to access a method. Like there is only a member of the child class, which is the getRadius, for example, and to access a method that is only a method of the parent class. And the general rule we said, just to remind you, is that maybe we redraw the figure that we have done last time. Assume the point is the parent class, and then we have this child class, which is the circle one. So we said any member variable or any member method of the point class, including, for example, getX, the one we tried last time, is also accessible by the circle class, right? So this is basically the meaning of inheritance. You inherit everything that comes from the parent to the child, including all the methods and all the member variables, right? And this is something that was very important. The other thing we mentioned is that if you have a method that is only declared in the child, something like getRadius, and we have an object of the point class. Do you remember what we said about this? Like, would this object be able to access the getRadius method or not? What do you think? So I have this child class that is called circle. It has its own method that is called getRadius. I go to the main, I declare an object of the class point. Sagnan, no, correct, Ola, thanks. Yes, so an object of the parent class has no access to the methods of the child class, right? And we give the example from the real world. It is like mammals, for example, is the general parent class, while horses can be the child class, like because horses are a subset of the bigger set, which are mammals, right? While horses, for example, have 4 legs, or they can run, for example, not all mammals can run, given like run is a method, for example, or not all of them have 4 legs, which might be an instance variable. So the general rule is an object of the parent class does not have access to the methods or the instance variables that are declared in the child class. Good? Perfect. Then we said an example like this. If you declare something, let's B2 is of point class, then even if we make it, we copy, and this is something I guess we didn't discuss in detail last lecture, so we'll discuss now. Assume I have, let me have an empty slide here to discuss. So this is our point class, and I assume I define an object of this point class that's called B1, right? So B1 is of type point, good? And then I define the circle one, like this is for point class, and this is C1, which is an object of the circle class. Good? Can I say something, first of all, can I write something like this? B1 equals C1. So if you remember, so no, which I said this. Okay, so why not? So remember that a critical point we said last time is any object of the child class is really also an object of the parent class. And that's the essence of inheritance, right? We said inheritance is a relationship or an object of relationship or an instance of relationship, which means C1, yes, it's an object of the circle class, but it's also an object of the point class, right? Because simply circle is the child of the point, right? So in this case, saying something like this is completely valid, because this is, if you remember from, forget about classes at all, remember like the inherent types of Java, int, double, etc. We said you can always cast, right? And there is casting that is done automatically or implicitly by the compiler, and there is casting you have to do yourself. Casting from the narrow type to the wider type, well, can happen automatically if you remember, right? I can say something like double x int y equal 10. You can say x equal 10, right? And then the compiler, sorry, I should say something like x equal y, right? In this case, moving y, which is of int type, which is the narrow type, to the x, which is a double type or the wider type, happens by default or implicit. This is called casting or widening, if you remember, right? then this is exactly the same rule we have here. Assigning a child type or object of a child type to a reference of the parent type is allowed. So that's no problem, right? So let's see what is the problem. The problem, if I say something like b1.getRadius, you might imagine, since b1 now is pointing to an object of the circle class, I can do this. Well, no, you cannot do this. Why? Because you look into the reference type. The reference type is of a parent class. So even if B1, by writing this statement, B1 will be pointing here, still it will not have access to the methods, something like getRadius, or the variables that are within the circle class that are not of type parent, right? So what is the rule? The rule is you can still have a reference of the parent type pointing to an object of the child type, but it does not have directly the access to even the child or the child methods or instance variables. Good. So going back to the example, here I define, first of all, I define B3 to be an object point. Then first of all, if I say C3 equal B3, which is the other way around, which is assigning something of parent type to a circle type, which is a child type, that's not allowed, because remember, this is narrowing down. It's like saying from double to end, you have to cast yourself, so that's not allowed. So, well, here you can cast, right? So doing something like this is completely equivalent to say int x, and let's say I have here double y equal 10.0 equal, to be able to assign y to x, I should cast, right? Do you remember this? So what is the rule we had for casting? Moving from a wider type to a narrower type would require explicit casting, right? Exactly the same thing. Moving from the parent type, which is the wider type, to, which is the superset, right? To the subset, which is the child type, the narrower type, you have to cast yourself. So if you cast, it will give you no syntax error. But that said, if you try to access any method of the parent thing, still C3, so basically still C3 is pointing to the object of type point. So that will give you a runtime error, right? So in order not to confuse you, just go then, well, so we discussed right now really two things. The first one is casting from the child to the parent. The second one from the parent to the child. We said this one can happen implicitly because it's like moving to a wider type, so the compiler will recognize this. This one would require explicit casting, right? So let's play around with this idea, moving from the child to the parent or the parent to the child, because it's important to understand. And then I will look into questions after looking into the example, because I believe most of the confusion will be removed when we look into a specific example, right? So assuming this example, I define C2, which is of type circle, which is a child. And then I would say point B2 equals C2, right? Based on the example we had in the animation, well, that's allowed, right? There's no problem of doing this, and that's of the first type. So it's an implicit casting, it happens by default. Good. And then if I say, for example, B2.getX, getX is a method in the parent, so that's completely fine. C2.getX, well, that's also completely fine. But then if I try to do something like B2.getRadius, this is what I was discussing in the drawing by saying, even if B2, let's see what is happening. First of all, C2 declared a place in the memory of object circle, and C2 is pointing into it. Then this is the first line. The second line, B2 equals C2, so I'm making B2 is pointing here. So even if B2 of type point is pointing to an object of circle point, still it doesn't see the instance method of variables of the child. So if you do something like this, this shouldn't work, right? This gives you a syntax error. Why? Because getRadius is not a method of a point class, while B2 is a reference of a point class. Questions? Let me take questions now. When would this casting be useful? I'm trying to see how I would apply this, Arjun. Yes, so the casting, it's really not about useful. It's mandatory if you want to move from, oh, I see what is the use case if I want to move from the child to the parent class. We will have practical examples right now. Mark, what happens to the variables in circle that are not in point when B1 equals C1? Well, that's also a good point, Mark. They are not lost, but they are not accessible by this reference, B1. You can still access them using the C1 reference. For example, here, I can write double R equal C2 dot get radius. And I would still be able to do this because C2 is of type circle, so that's allowed. So they are still there in memory, but you need the correct reference type to be able to access them. C2 equal B2. So Yanhao, if you do C2 equal B2, B2 is null, right? Because nothing is allocated in memory, right? So well, you cannot just really access any method in this case. If you are asking the general question, Yanhao, what if you have an object of the type point and you have a circuit that is accessing it, what would happen? We will discuss this next, right? Salah, can you still do C2 to get? Yeah, this is exactly what I was saying right now. Good. So now let's do the other way around, which was Yanhao question, which is I have an object of type point here. I declared inside the memory an object of type point. This is an object of point, and then I'm making B3 pointing into it. Later, I say C3 equal B3. First of all, this is a syntax error because based on our discussion, this is moving from parent type to a child type. So you need casting, right? So you have to do something like this. Good. So you have to cast to the circle type. Then afterwards, if you try to access anything, so simply it tells you that there is an exception at runtime because the object referenced by B3 is not of a circle type. What does it mean? Well, it allows this to be done. It allows you to have C3 pointing here. So it doesn't give you a syntax error because it's syntactically correct, right? But the problem is C3 of type circle, and we said that the child, so let's look here. You remember mammals and horses. This is the subset. This is the superset, right? Then with the same analogy, we would have the circle here in our object C3 of type circle, while point is the parent class. At runtime, this simply, so every horse is a mammal, but not every mammal is a horse, which means this C3 cannot simply point to something of type point because it's a superset, right? So parent can point to a child, but child cannot point to a parent, right? I know it might seem confusing, but we will see a few examples to illustrate this, right? Okay, good. So let's see another way of doing stuff. So here, again, I declare another point reference. And why this example is very important because we need to differentiate between two different things. The first thing is the object itself. And we said this before, but really it didn't appear useful until now, until this example. So we have the object itself, which is the allocation in the memory, and we have the reference that is pointing it to it. So we call this object and we call this reference. And these two are really distinct, and they have to be distinct in our minds, right? Because this is the way you can understand the relationship of inheritance. For example, here I'm defining a reference of type point while making this reference point to an object of type circle. Is this allowed? Yes, for sure. We have just done it in the previous slide by saying B3 equals C3, for example, right? So this is of type circle, which is generally the child, and this is of type parent. And that's allowed without even a need for casting. And the reason for this is it's moving from a narrow type again to the wider type. So it's an implicit casting. But you cannot access the methods. So I assume I want to do the other way around. I want then B4 to be assigned to something of type circle, C4, right? First of all, you would require the casting, because without the casting, it wouldn't be possible because it's moving from the wider to the narrower type. Then the second thing is, what is the difference between this example and the previous example? We said this is going to give you a runtime error, and I explained to you why. But now, this is not going to give you a runtime error. Can someone kind of explain to me or imagine or think why this will work, why the other example will not work? So what is the main difference between this and this? Based on our discussion of the differentiation between the object and the reference. What do you think? Let me give a hint question. So let me see into the results here. Katie, the reference of the point class is point to an object of circle class. Can you repeat? Yeah, now on the first line that, yeah, that's exactly, before is a circle type, John. That's also correct. So John and Katie, you are correct. The main difference between this example and this one is here the object itself. If you look, that's the object, right? Of type point. So C3, which is of type circle, which is a child, cannot point to an object of the point type. While here, the object itself is of circle type, which means C4 can correctly point into it, right? If I do the casting properly, right? Is that clear? Are there any questions? Yan Hao, can you repeat what happens on the first line, the line point for equal new thing? Here, right? So what happens here is I'm just simply creating a reference of the parent type and then creating an object of the child type and making the parent point into it, right? So it's completely equivalent as if you say circle C1 equal new circle and then equal point before equal C1, right? So, and we said that's completely fine because a parent can point to the child, right? Are there other questions? Okay. So this is the widening thing we were discussing. Again, to summarize, moving from here is the child type, here is the parent type. Moving from the parent to the child would require casting because this is narrowing, right? While moving from the child to the parent, well, it happens by default. You don't need to worry, right? This is the first rule. The second rule is a reference of type child will have to point to an object of type child, right? Otherwise it wouldn't work. While on the other hand, a reference of type point, I guess I went lagging again. Okay, so let me repeat. I guess I'm back. So what I was saying is the first rule is casting is required from parent to child, while from child to parent is not needed. That's the first rule. Second rule is you have two things. The first one is the object in memory is of type child, the circle, for example. Then the parent can point into it. A reference of type parent can point into it. That's completely fine. While having an object of type parent, our point class, for example, a reference of type child, a circle class, for example, will not be able to point into it. Well, it's not a syntax error if you do the casting, but during runtime, that's not allowed. These are basically the two rules you need to know about the relationship between objects and references, right? If you go back to the C terminology, a reference is nothing other than a pointer. It's the address of this object in the memory, right? While the object is the actual object itself, the actual memory location, right? This is also how you can differentiate between both. Good? Okay. Here's another example. I guess we already discussed this. So, well, the other thing that I guess would be better to ask as a question, assume now I have an object of type circle, which is the child, right? Circle. I have some methods which are inherited from the parent method, something like getX. I have other methods that are of the child type, something like getRadius. I told you that a parent reference can point to the child. So, right, this is circle or child. And this is point, let's say B3 point, or the parent, right? I told you that B3 can point to this object, but it will not have access to the getRadius method or any method that are declared, any method that is declared within the child, right? What should I do to be able to access it, right? I guess Jack or Mark, if I remember correctly, asked the questions, are these still accessible? What happens to them? And I told him, if you want to access these, you want to declare a reference of the child type, something like circle C3, for example, right? Can I do this without declaring another object or another reference? Yes, you can do this with casting, right? Because if I write something like B3 and then cast it to circle, now what is the type of this reference right now? Originally, this was point, right? But the overall reference after casting, what do you think? What would be the type of this reference right now? Circle, Yan Hao and Hao Yu, yes, correct, thanks. Which means if I do something like this and then say dot get radius, it would still be allowed, right? And that's exactly what we have here. I had a reference of type point. I casted it to a reference of type circle. The object itself, most importantly, is of type circle. Then accessing the get radius will be allowed, right? Are there any questions in this example? Do you always need to cast if I want to do this? Yes, Yan Hao, because otherwise a reference of type parent have no access at all to methods of the child, including get radius. So you have to cast to the child to be able to access them. What if I want to do something like get x? In this case, you don't need to cast. You can just simply say b4.getx. Why? Because getx is visible to the parent, right? So no casting is required in this case. Sarah, that's an excellent question. Why do I need to cast to circle if the object is already circle? Because the object is circle, but the reference is point, which means the elements in the object that are associated with the child, the circle, are not visible. They are there in the memory, like here, for example, but they're not visible to the reference, right? That's the main reason why we need to cast or use a reference of type circle, because, well, a point type have no access to get radius. Get radius is not a member of a point type. Mark, can the child not point into parent object because they are not memory allocated for variables in the child class in that parent object? Can the child not point into parent object because there are allocated variables in the child class in that parent object? I'm not sure if I understand the question, Mark, but I believe you are trying to justify why a child reference cannot point to a parent object, right? The main reason for this is it's a wider type, right? So basically, you cannot access something that is not your type, right? Why the parent was able to access the circle type? Because we said before, an object of a circle type is also an object of the parent type, right? That's the is-a relationship for inheritance. So the general rule is any reference cannot point to any object other than its type, right? Well, even inheritance is not an exception, but we know that even if this is a circle object, it's also a point object. Remember, this was the main point of inheritance. This is why a point class can point into it. But not every point object is a circle object. And that's the main reason why the child cannot access, a child reference cannot access an object of the parent reference, right? Good. So trying to exercise this with more examples will help you understand the different things, right? Yeah, this is the basically again what I was just saying right now for Mark is that an object of the subclass is it has an is a relationship or is an object of the superclass, right? Well, that's all what we were saying right now, and you would require casting. Okay, good. So if before moving to the other slides, let me go back to the example we had last time in online GDB. And let's play around with it, similar like to apply what we just learned, right? Remember what we had last time is a point class, a circle class that is extending the point class, and it has its own get radius to string and etc. etc. So in the main here, let's try to play around with a few examples, right? First of all, I'm defining my circle object to be of type circle. Then I know, or you know what, maybe first of all, let's try something like this. Let's try all the things we discussed. Can I do something like this? 0, 0, for example. What do you think? Would this be allowed? Making a reference child is pointing to a parent object based on our discussion. Is this allowed? No, 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 no. That's perfect. Thanks, everyone. So this should give you a compiler error syntax error. Good. Then, if I try something like this, let's try this is of circle type. So let me just do this. And then make this point, and this is my point. The other way around. A reference of type parent is pointing to an object of type child. First of all, is this allowed? Yes, right? It's allowed. But then, if I go here and I write something like my point dot get x, and this has to be taken into int x equal this. Would this be allowed? What do you think? Well, yes, for sure. And what is the reason? Is that getX is a method of the parent type, so it's still allowed. So if we run this, hopefully things should work fine. And well, as usual, the autocomplete messed things out, but let's rerun. Well, yes, we have x equals 0 and it works fine. Why? Again, because getX is of this method. So let me try another thing. Something like int r equal my point dot get, oh, was this get radius? Yeah, this thing. And then I will try to print the radius. So r equal r. What do you think of this? Would this work? No, you have to cast child method. Sorry, that's correct. It doesn't work by default because simply get radius is of child method, and it, like the point doesn't have direct access to it. Well, so if I run this, it tells you that, oh, cannot find symbol is not part of the point class, right? Then what to do? As we just discussed, to be able to do this, I need first of all to cast my point to the circle type. So I should just write circle for casting. And then now the overall reference will be of circle type. And hopefully this should work, right? So if you try to run. Well, possibly losing conversion from double to end. Oh, because it's type double. And we needed to cast, right? That's ironic. Good. So this works now. Why? Because again, I converted the parent reference into a child reference, and now it gives me access to the child methods. Good? Okay, perfect. Well, is there anything else that we discussed that we need to simplify? So moving from parent to child, from child to parent, a parent has access to the child object, but it has no access to the methods until you cast, right? I guess that's all. Good. So let me now build on top of that and do more interesting stuff. I guess I need to close full screen.
Excuse me?
Yeah, go ahead, Yanhao.
Can I ask a question? Like, can you go back to your code?
Sure.
I'm wondering what happens if you override one of the method. Like if you have a child class, for example, circle override a method of point class, and then you do exactly what you did at here. What
so which one of them? Something like this, making the reference?
Yeah. If
okay,
you have also get x in circle.
That's an excellent point, Yanhao. We already have the toString method overwritten already, if you remember, right? So let me do something like my point dot toString, right? And let's see if this works. Which one is going? So let me first ask. That's a good point, Yanhao. I usually have this as a trick in the exam. So let me ask, what do you expect to be printed out? Right now, I have a reference of the type parent. I have a method that exists in both, in this case, in the child and in the parent. And well, using it with the parent type, what would you expect to get? Are we running the toString at the parent or the toString at the child? The parent for sure, right? Because by default, the reference of type parent has no access to even the toString of the child, right? So it doesn't see it, right? So if we try something like this, well, no. What happened then? Why that's the case? We all said that it should be the parent type. What do you think? Why what happened is not as we expected or the intuitive thing? And that's the essence of the trick, right? Any intuition? Can someone imagine why that's the case? What do you think? Let's just focus on the one that we have. The object is circle, Salah, that's one thing, yeah. What did we call this? The object is still child, that's correct, Katie. Yeah, that's correct. So the object is of type circle, that's one thing. The second thing is, if you remember, having two methods, one at the child and one at the parent, what did we call this? We call this method overriding, right? Right? Which means simply the one at the child overrides the one at the parent, right? You see the point? So your object type, so well, the parent type, so let me go back to visualization. And I thank you again, Yan Hao, for the question. So let me go back here. Let's have an empty slide and let's explain what happened. So I have the circle in the memory object, right? That's of type circle. It has all the methods. It also has the toString method. And I have my point, if I remember the name, was pointing here. So well, I know that my point has no access to the methods that are only in the child class. But toString is not only in the child class, right? It's also in the parent class. Now the question go back is which one to pick, right? And who answers this question is the method overriding. If you have the same method at the child and at the parent, you pick the one that is at the child, right? So the visibility here includes the methods that are also defined in the parent. So my point class, even if it doesn't have access to getRadius, for example, it has access to the toString because this method apparently is also part of the parent, right? And you pick the one that is at the child. So going back to a question that we had in last lecture, what if I want to access the one that is at the parent? What should I do? Cast point. So, but my point is of reference of type point anyway, right? Super.toString, but this super, you cannot use super outside the child class. We cannot use super in the main, right? That's not allowed. I'm asking, what if I want to access it? Define a point as a class point, not circle. Yes, but Sandy, you said it correctly. I see what you mean, but it's a different terminology. Define mean declaring, and really my point is of type or declared or defined as a point. But what you meant is create an object of the type point, right? That's the whole thing. So here, the object itself is of type circle. So if I want to access the toString of the point, I need my object to be of type point, right? And in this case, the toString will be the one that is at the parent, right? Good. Okay, good. So yeah, I hope that's clear right now. Could you cast and then use this.toString? First of all, this cannot be used outside the class itself, Jack. It cannot be used in the main. And then, well, I don't need to cast. It's already of the type parent, right? So why casting might work, right? That's So the whole thing is not about the reference type, it's about the object type. Here, the object was of the circle object, while if I want to access the parent one, I need the object to be of my type parent, right? Okay, thanks everyone. That was a good trick. But I guess you should be happy that you had this during the lecture, not during the exam. Okay, so now let's build on top of, well, I need first to go full screen, discard, and then share the other one. Well, we have only 10 minutes remaining, but that's fine. I guess, well, the topic of this lecture is also containing this kind of trick discussion, which is related to the method overriding, right? So it is very interesting to discuss. And to be honest with you, on online GDB, yes, Katie, I will go back into it. Hopefully, we would have a couple of minutes towards the end to try some of these things, and I would also try the one that we tried. So dynamic method binding. So one of the, so far, and I guess this is related to Arjun's question back during the lecture, which is, well, what is the use case of casting? What do I do with this old casting thing? Is it only annoying? Is it only for exam tricks? Does it have any useful use case? And this lecture will show you the powerfulness of inheritance, why it's really very dynamic, right? It allows you to do some kind of code statically, but during runtime, you can really choose which method to run based on certain metrics that you didn't know statically, right? So it allows dynamic running of the code. This way it's called dynamic method binding. So you choose which method to run during runtime, not during static time, right? And this makes like very, very powerful coding if you wish. I will forget all of this and jump directly to an example to explain to you the idea. Assume I have something like this example, which is I have two string methods similar to what we had before. One at the parent or the superclass, and one at the child class or the what we call the subclass, right? And then inside the main, I'll play around with all these kind of object stuff that we had discussed. For example, I define a reference of type child, my sub, and is pointing to my sub. Let's take them one by one. So if I do p.toString, what do you expect to find as an output? Given that simply, so, okay, first of all, how do I approach this problem? I should ask myself two questions. The first one is, what is the object type and what is the reference type? In case of B, it's really straightforward because the object is of type sub and the reference is of type sub. So what would you expect the first statement to print? My sub, right? That's very simple. It has nothing to do with inheritance at all, right? You have just a class that you are defining an object out of it, a reference of the same type, and you print it. So it gives you my sub. Perfect. So that's easy. Let's start to complicate things a little bit. Now I define a reference of type parent, and I assign it to an object of type child, right? That's exactly the trick we just had right now for point and circle, right? What you'd expect to print as an output in this case? My sub, right? So now your answer is different, right? Previously you answered, oh, parent for sure. Now you got it. So that's perfect. So it will be again my sub. The reason is, again, the object itself is of type sub, right? So method overriding will give you the sub one. Good, thanks. Then the third one is also the straightforward one, which is you have the reference of the super or the parent type, and well, the object is also of the parent type. So the last one is my super, like the parent one. Perfect, thanks. Good. So what did we do here? If you look into what we have discussed, the trick and these examples, it tells you that really the method that is running here, all of them are the same static code, right? But the method that is baked during runtime will depend on the object type, correct? If the object is of type child, you print the child one. Is the object of type parent, you print the parent one, correct? And this is called dynamic method binding because this is determined during runtime. Excuse me, right? This is determined during runtime, not during static time. So how can I, so we discussed this already, and this gives us another related concept, which is called polymorphism, right? So this word is a kind of a buzzword for object-oriented programming, and really the meaning is very simple, right? What is polymorphism? Simply, I would say the dictionary meaning of the word means many forms, right? And if you look into the toString method here, the toString method has many forms, right? Which in software language, it has different implementations, right? It has like multiple faces, and which one to pick will depend generally on the context, right? On the object type. Why that's, as I was saying, why that's one of the most powerful things about object-oriented programming, because simply I can create a code that is generic enough to allow the same code to run differently based on the object type, right? Or the method type during runtime. How to do this? Let's pick one example, and I guess we'll not be able to implement the example during this lecture, but we will start next lecture with this. So previously we had the point as a parent and circle as a child of that parent. But I guess I told you last lecture, it might be more useful, more generic to define our parent class to be the graphic object. I call it graphic object or my graphic object, whatever. And this one, I can use it to instantiate or to create childs of all the graphic shapes: circle, triangle, rectangle, square, point, whatever you prefer, right? This allows you to have your own library of class shapes, right? Based on this graphic object. So here, graphic object is the parent, and everyone is the child, right? Well, how polymorphism can help us in this case? Assume you already have your implementation of these, right? Oh, I got disconnected. Well, that's really good. So I guess I'm back right now. But I don't know what is the last one you have. Okay, so let me reiterate quickly. What I was saying is, previously we had the parent as our point class and the child is the circle class, right? Right now, we would be more generic. We would create our own library of shapes. This will be our example for this lecture and coming lecture, and we will code it together in coming lecture. So simply, you would have a parent class of graphic object type, and you can create childs out of this graphic object of different shapes, like triangle, circle, rectangle, square, point, whatever, right? And then we will see how polymorphism can help us here. So let me quickly introduce the concept, and you have the slides, go through them, and next time we implement them together. So for each of these shapes, if you remember high school geometry class, for example, you need to calculate the area, for example, or the perimeter of any shape, right? If you don't know inheritance, you would have to implement your area for every one of these classes, and is completely disassociated from each other. While by knowing inheritance, what can I do? I can simply have an area method inside the parent, and then a specific implementation of the area inside each of the childs based on dynamic method binding or method overriding or polymorphism. Well, if I create an object of this type during runtime, if I call area, then this one is going to get executed, correct? While if I create the object of this type, this area one is going to be executed. Am I correct? So looking into the example here, I can create all my objects of the type parent, which is my graphic object, as I do here, right? Look here, I create a reference of graphic object type, and then I create an array of these, basically like a 100 shape data set, right? And then this is the reference type. And then later in a loop, I allocate the memory. So this is the object type or the allocation in the memory. I basically go through them one by one. I create point, rectangle, triangle, circle, and then go back and do the same thing, right? Which means the reference is of the type parent, but objects have different types on the same set, right? On the same array, good? And then assume I have a method that is called, for example, calculate largest area, to show you how effectively things can run. So simply, I can refer to any entry of the array by GI, where G is of parent type again, right? This is the parent reference, right? While dynamically, based on GI object type, the area will be calculated differently. For example, if this was circle, it will be pi r square. If this was triangle, it would be, if this was like, yeah, triangle, it's like half, whatever. And then if this was square, it would be x square. If it was rectangle, it would be x multiplied by y, whatever equation you would put in your shape, right? So this piece of code, as you can see, is very concise. It's independent of the object type. It has exactly the same call for the area method, while dynamically, area is really different based on whatever you have: circle, you have point, you have rectangle, whatever, right? And that's really what we mean by dynamic method binding or polymorphism. I can dynamically choose which method to bind to this call based on the GI type of the object. Good. I know that's too much detail and we went over time. So I will stop here, and next time we'll start by implementing it and seeing it together. Remember, today after lecture, I have my office hours. So after 5 minutes, I will be using the office hour link for taking questions and help you if you have any problem with the lab as well. But let me remain here for a couple of minutes to take questions before we leave. Thanks, everyone. We are done with the technical content, but if you got questions, you are free to stay. Arjun, so we create it in the parent, but the parent implementation isn't meant to be used. And instead, we make it the subclass can override. Exactly, Arjun. That's the whole point. You create a placeholder, a template at the parent type, which can be overwritten by whatever child you create, right? And that's really a significant idea for object-oriented programming that we will extend later by having class interfaces, for example, something like just a shape, right, of the class, but it really has nothing to do other than just being able to be inherited by other classes. Katie, so what would the implementation in parent be? Or it will not matter? Exactly, Katie, it will not matter. For example, in this graphic thing, we'll see next time is we'll just area will return 0, for example. It does nothing, right? Because we know based on the shape, the graphic object itself is nothing. So it has no area. We don't know what is the shape, right? And based on the shape type, we will calculate it correctly. That's correct. Okay, so are there any other questions? Thanks, Arjun. Thanks, Katie. Okay, so if that's the case, yeah, Arjun, all last week lectures are posted, but I guess your friends are saying that Friday one is not. So I would check this, make sure if it's visible in the playlist. Yeah. Okay.
Hello?
Yeah.
Can you briefly give a conclusion of the parent class and child class, like how they casting to each other?
Yeah. So yeah, good. So a summary. So we'll also revisit this in coming lecture by the implementation of polymorphism. But if you want a summary of what we discussed in this lecture, the summary is the following. A reference. So we have two things: object and reference. The object itself is really what matters. So if you have the object of type child, a parent reference can point into it, and for sure a child reference can point into it, right? But if you have an object of type parent, first of all, the child will not be able to point into it. Well, you can cast it, but it will not, during runtime, it will give you an error. That's the first thing. The second thing is, if you have a parent reference and you have a child object, the child object has two different type of methods and instance fields. The first one are the ones that are inherited from the parent, and the ones that are specific to the child. A parent reference has access to this, but it does not have access to this. These 2 points are the summary of all what we discussed today, right? Is that clear?
Yeah, that's really clear. But one thing I still not really understand is like, did you say you can cast the child class into parent and then pointing to the parent class?
Yeah, so what I said is by this casting, you will not have a syntax error, but during runtime, if the object itself, so assume, for example, I have something like this. I have a child object, I have a parent reference. Later, let's call this my parent, okay? If I write something like my, and assume that child class is called child, my child equal my parent. Well, first of all, you need the casting here. So you write child. And if you do this casting, that's fine. Why this is allowed? Because, well, that's a reference of type parent, but what is the object type? It's child, which means a reference of type child will be able to access this, right? That's what I said about it, right?
But you say it gives you an error.
Not this one.
Runtime
The one
is-
that gives you an error is that if the object of type parent. This now, even with casting, will give you a runtime error because the object itself is of type point, while the reference is of type child, or a parent and child, right? So
Can you say
need,
that again for your
yeah, sure. What is the rule?
last
Sure.
statement?
Let me say, what is the rule? If you have a reference of type child, you must have the object of type child. Otherwise, things will not run, right? That's basically the golden rule, right? Does this make sense?
Not really.
So simply, if you have an object of type parent, you cannot use this with a reference of type child. So that's all, right?
Even with the casting?
Even with the casting. Casting will save you from a syntax error, but it will give you a runtime error. So even with the casting, a child reference cannot be used for a parent object.
I see.
Yeah.
I see. Thank you.
Yeah, welcome. Muaz, can you repeat what you said about what the parent area method would hold? The parent area method. I guess if you are referring to the area here in the graphics object, we will repeat this, Muaz, at the beginning of next lecture, so don't worry about it. Rookie, does it mean the reference can only go narrow but wide? With regard to casting, you can cast from both directions, but whether this will work or not during runtime, that's the different story. So the rule is in classes, I'm not talking about inherent types like int or float, I'm talking about classes. You have to make sure, again, if you have the object of type parent, the reference has to be of type parent. It cannot be of type child. That's basically the general rule, Rookie. Okay. Okay, so by this we can conclude. Thanks everyone, and as I said, after maybe a few minutes, I will be in the other link for office hours, and talk to you all tomorrow. Bye bye.